So we've got 3y squared plus 6x to the third, and we're raising this whole thing to the fifth power. And we could clearly use a binomial theorem or Pascal's triangle in order to find the expansion of that. But what I want to do really as an exercise is to try to hone in on just one of the terms. And in particular, I want to hone in on the term that has some coefficient times x to the sixth y to the sixth. So in this expansion, some term is going to have x to the sixth, y to the sixth, and I want to figure out what the coefficient on that term is. And I encourage you to pause this video and try to figure it out on your own. So I'm assuming you've had a go at it, and you might have at first found this to be a little bit confusing. I'm only raising it to the fifth power. How do I get x to the sixth, y to the sixth? But then when you look at the actual terms in the binomial, it starts to jump out at you. Okay, I have a y squared term. I have an x to the third term. So when I raise these to powers, I could have powers higher than the fifth power. But to actually think about which of these terms has the x to the sixth, y to the sixth, let's just look at the pattern in I guess, the actual expansion without even thinking about its coefficients. And we've seen this multiple times before, where you could take your first term in your binomial and you can start it off. It's going to start off at the power we're taking the whole binomial to, and then in each term it's going to have a lower and lower power. So let me actually just copy and paste this. So this is going to be, so copy, and so that's first term, second term, make sure I have enough space here, second term, third term, fourth term, fifth term, and sixth term. This is going to have 6 terms to it. You always have one more term than the exponent. And then, actually, before I throw the exponents on it, let's focus on the second term. So the second term, actually, I'll write it like this. So the second term is times 6x to the third. Let me copy and paste that. Whoops. So let me copy and paste that. So we're going to put that there, that there, that there, that there, and then over, actually off your screen. I wrote it over there, and we'll see if we have to go there. And then let's put the exponents. So this exponent, this is going to be the fifth power, fourth power, third power, second power, first power, and 0th power. And for the blue expression, for 6x to the third, this is going to be the 0th power, first power, second power, third power, fourth power, and then we're going to have the fifth power right over here. And of course, they're each going to have coefficients in front of them. They're each going to have coefficients in front of them. So there's going to be a coefficient in front of this one, in front of this one, in front of this one, and then we add them all together. But which of these terms is the one that we're talking about? It has x to the sixth, y to the sixth. So here we have x, if we take y squared to the fourth, that's going to be y to the eighth. So that's not it. If we go here, we have y squared to the third power. That's y to the sixth. And here you have x to the third squared. That's x to the sixth. So what we really want to think about is, what is the coefficient? What is the coefficient in front of this term? In front of this term going to be? Essentially, if you put it in this way, it's going to be the third term that we actually care about. So what is this coefficient going to be? Now we have to be clear. This coefficient, whatever we put here, that we can use the binomial theorem to figure out, isn't going to be this. This thing that we have to, I guess, our actual solution to the problem that we posed is going to be the product of this coefficient and whatever other coefficients we have over here, because we're going to have 3 to the third power, 6 squared. So we're going to have to figure out what that is. But let's first just figure out what this term looks like, this term in the expansion, what this yellow part actually is. And there's a couple of ways we could do that. We could use Pascal's triangle, or we could use combinatorics. If we use combinatorics, we know that the coefficient over here, this is going to be 5 choose 0. This is going to be the coefficient over here is going to be 5 choose 1. And we've seen this multiple times. You could view it as essentially the exponent choose the or it's the top when we the 5 is the exponent that we're raising the whole binomial to, and then when we say choose this number, that's the exponent on the second term, I guess you could say. So this would be 5 choose 1, and this one over here, the coefficient, this thing in yellow, this is going to be 5 choose 2. 5 choose 2. Now, what is 5 choose 2? Well, that's equal to 5 factorial over 2 factorial times 5 minus 2 factorial. So let me just put that in here. Times 5 minus 2 factorial. And this is going to be equal to, let's see, 5 factorial is 5 times 4 times 3 times 2. We could write times 1, but that won't change the value. Over 2 factorial. Actually, let me just write that just so we make it clear. It is times 1 there. 2 factorial is 2 times 1. And then what we have right over here, this is 3 factorial. So times 3 times 2 times 1. So let's see. This 3 could cancel with that 3. That 2 could cancel with that 2. The 1s don't matter, won't change the value. And then 4 divided by 2 is 2. So that is just 2. So we're left with 5 times 2 is equal to 10. So that's going to be this number right over here. This is going to be a 10. Now, another way we could have done it is using Pascal's triangle. We could have said, OK, this is the binomial. Now, this is when I raise it to the second power, is 1, 2, 1 are the coefficients. When I raise it to the third power, the coefficients are 1, 3, 3, 1. When I raise it to the fourth power, the coefficients are 1, 4, 6, 4, 1. And when I raise it to the fifth power, which is the one we care about, the coefficients are going to be 1, 5, 10, 5, or sorry, 10, 10, 5, and 1. And we know that when we go for, this is going to be the third term. So this is going to be the coefficient right over here. 1, 2, 3, third term. So either way, we know this is 10. But now let's try to answer our original question. What is this going to be? What are we multiplying times x to the sixth, y to the sixth? And now we just have to essentially rewrite this expression. So it's going to be 10 times 3 to the third power, 3 to the third power, times y squared to the third power, which is y squared to the third power is y to the sixth power, y to the sixth power, times 6 squared, so times 6 squared, times x to the third squared, which that's x to the 3 times 2, or x to the sixth. And so this is going to be equal to, let's see, it's going to be 10 times 27 times 36 times 36. And then we have, of course, our x to the sixth and y to the sixth. So this is going to be essentially, let's see, 270 times 36. So let's see, let's get a calculator out. 270. I could have done it by hand, but I'll just do this for the sake of time. Times 36 is 9,720. So that's the coefficient right over here. It's going to be 9,720 x to the sixth, y to the sixth. 9,720 x to the sixth, y to the sixth. And we're done.